Today I'm going to be going over the 2020 AS FP1 paper. So yeah, I hope this is useful to you guys. So, question 1 gives us a second order differential equation and some boundary conditions, and also tells us we need to use these approximations, so the second order approximation and the midpoint formula, to work out basically y2. And I know it's going to be y2 because it says x0, so x0 equals 0, so x0 equals 0. And we want x2 using h as 0.1, so therefore it's going to be the second iteration of y. It's quite hard, I think, this question, because it doesn't really... You're going to need y1 in order to find y2 using either formula. And the only way to do this is by forming simultaneous equations, but I think it's quite... I haven't really seen too much of that before. But what we can do... Firstly, we can work out d squared y over dx squared 0 by plugging in our boundary conditions here. And that tells us that d squared y over dx squared 0 is just minus 1. So then we know that with this equation, when n equals 0, we're left with minus 1 is pretty much equal to y1 plus y minus 1, because this is y0, y0 is 0, over 0.1 squared. That tells us y1 plus y minus 1 is minus 0.01. Doing a similar thing with this side, again, we know dy over dx 0, and then, we can basically form another equation, which tells us that y1 minus y minus 1 is 0.6. So these are our two equations, and then adding them together, we can get 2y is minus 0.59, so y1 is 0.295. And of course, our x1 is just going to be, 0.1, because we're just adding h. Cool. And then we can work out d squared y over dx squared 1 using the same formula at the beginning, but this time with y1 and x1. And that tells us that this is going to be minus 0.295, whatever. Obviously, use more decimal places in your actual answer. But yeah. Cool. Now we kind of have all the values we need to work out y2. So if we do n equals 1 in this formula, well, we're obviously going to have y2 minus 2y1 plus y0 divided by h squared. And, we know this variable, we know this one, we know this one, we know this one. We know everything we need to find y2. So rearranging, we get this kind of result here. And yeah, we can just use that, plug in all our stuff, and that tells us y2 is 0.581. Yeah, that's the first question done. Cool. Question 2. Right, so with these inequality questions, the first thing I always do is find, the roots. So the zeros on the denominator, basically. Because these are our critical values. And normally, finding these roots we would do by, timesing each side by, x plus 3 squared, 2x minus 1 squared. You know what I mean? That's probably how you've been taught. But realistically, and on mark schemes, it lets you just say these are the critical values because they make the denominator 0. And then we don't have to worry about that squared part. So just timesing across, imagine this was just pretty much just a normal equals sign. Well, we just want to find out when that's greater than 0. So moving this to the left-hand side and factorizing a bit. Never multiply these all out, by the way. We have all of these brackets. If we want to multiply them out, that'll take ages. We just want to factorize it as much as we can first. And effectively, that just factorizes down to this. But x squared plus 1 is greater than 0 for all x. So there's no critical value. We don't care about it, pretty much. So we only have these 3 critical values. And of course, this is going to form a cubic. And we know it's going to be a positive cubic because, just looking at our x coefficients from the start, when they multiply, the coefficient of x is going to be greater than 0. So then we're just looking for when this cubic is greater than 0. And of course, that's going to be between minus 3 and minus a half, and when x is greater than a half. Cool. Much easier than the other one. Okay, 3i. First part was very strange. I didn't like it. It was just long. But basically what we're doing, well, we know that tan x is, of course, tan x plus 2 over x plus 2. Using the addition formula for tan, we can write it like this. So yeah, you know that probably. Which of course is 2t over 1 minus t squared. So therefore, cot x is 1 minus t squared over 2t. So therefore, cot x plus tan x over 2 is this, which is also 1 plus t squared over 2t. And in these exams, we're allowed to treat this as a standard result. Sine x is 2t over 1 plus t squared. So therefore, cosec x is 1 plus t squared over 2t, because it's just, 1 over sine. Which is, I mean, these are two equal things, so we can just say QED, which just means proved, if you didn't know that, pretty much. Next part. Oh, that's meant to say A, oh well. We're basically saying, when x is 0, what is h? All we have to do is sub 0 into these. Very, very simple. Pretty much that just tells us 90 minus 30, which is just 60. Cool. The next part, we're using t equals tan 60x. So if this was tan like theta over 2, then tan theta would equal tan 120x. So this is like basically cos x and sine x, if that makes sense. So we can just use we can use sine 120x as 2t over 1 plus t squared, and cos 120x as 1 minus t squared over 1 plus t squared. We just have to sub these in now, really. And they have the same denominator, which is quite nice, because then we can just multiply the 90 by 1 plus t squared. And this kind of simplifies really nicely down to this, which is what it wanted to show. Cool. And then part C, we want to find the value of x when the blade is like 100 meters above the ground. So we can, again, very easily do this if we just make h equal to 100, because that's the height we want. So imagine this is equal to 100. And then we times by 1 plus t squared. Then all we have to do is solve this quadratic, which, we can divide through by 20 here. And then complete the square at the end, because this isn't going to factorize nicely. And then, yeah, so that tells us that 60x is arctan 2 plus or minus root 6. And of course, x is greater than 0, because we can't have a negative height, at least, in this situation. So yeah, x is going to be the positive one, which is arctan of the positive one, which gives us 77.33. So therefore x is 1.29, and yeah. This was the hardest question on the paper, in my opinion. So yeah. It tells us first to work out the coordinates of S, and of course this is just a parabola in a standard form. Y squared is 4ax. Y squared is 4ax. So of course that just tells us the focus, which is S, is A, so A0. The next part tells us to write the length of SP in terms of A and P. Cool. So this part, I think you could do it by working out a triangle, working out this length, doing like Pythagoras. But we also know that with a parabola, the whole point of a parabola is that the distance SP for like varying P is the same as the distance AP for like varying A as well, if you get what I mean. So all we have to do here is, work out the x coordinate of this and then add it to the x coordinate of that, because they're negative. So this line A is the directrix, which has the equation x plus A equals 0. So, the coordinate of A is minus A to AP. Therefore, the distance between A and P, we don't have to consider the y's because they have the same y coordinate, is AP squared minus A. And yeah, that's the distance. Cool. Last part was really weird. Basically, we have this other point, Q, which is somewhere on the curve, and we want to find, and we have M as the midpoint of PQ, and we want to find the locus of M as P varies. So as P moves up, where does S go, basically? And how we do this, like a good starting step, because it says M is the midpoint of PQ, maybe we just want to find M. So we can easily find this. We know the x and y coordinates of P and Q. Just using them, we get the midpoint. Cool. And then this tells us that the y coordinate of M is A times P plus Q. So therefore, just looking at this kind of form up here, we want a y squared in there. So let's just square both sides, see what happens. Squaring both sides, we get y squared equals a squared plus a squared times p squared plus 2pq plus q squared. And it tells us earlier that pq is minus 1 up here. So we can just replace this with minus 1. And that tells us that y squared is a squared times p squared plus q squared minus 2a squared. Cool. And also we know that the x coordinate of m is this, right? Which is also just equal to 2 times x. Well, this is equal to 2 times x, therefore. Obviously factoring in one of the x's into those brackets. So yeah, and then we're left with this, which we can very easily just factorize down into this, which is what it wanted us to show. But yeah, I think that was the hardest question on the paper, so don't worry if you got that wrong. This one was also quite hard though, to be fair. So A asks us to find the area of the triangular face DEF, or show it is this. Pretty nice. So all we have to do, work out two kind of vectors on this face facing like into each other, but away from each other. So E and D and E and F. Find them very easily, just like year one stuff, you know, minusing them from each other. We get both of these. And then obviously to work out the area of DEF, we're going to be using a half times the magnitude of the cross product of those two vectors, so ED and EF, which is just going to be a half times the absolute value of the determinant of this matrix. I'm kind of overcomplicating this, but you could just do this all in your calculator, so don't stress it. Which basically gives us minus 1 minus 7, 17. Then doing Pythagoras with them, so 1 squared plus 7 squared plus 17 squared, square root. We get that's equal to root 339. So a half root 339. Cool. So now for part B, we're asked to work out the exact volume of this display stand. And what you might notice is this is just a tetrahedron with the top kind of like section removed. So if we were to work out the volume of this tetrahedron, if this side was there, and then kind of work out what's missing, then we can work out the area of the shape. So first thing to do is work out the scale factor between AB and DE, because these are obviously two kind of similar triangles. So ED, the magnitude of ED, or DE, is root 26. The magnitude of AB is 2 root 26. Therefore, ED to AB is 1 to 2. So, therefore, the volume scale factor is going to be 8, because it's like 2 cubed. Cool. If we call this point up here X, so imagine this was kind of the top of the shape, then AD is going to be equal to a half of AX, because if this side is halved, then we have double the distance to go till it reaches 0, if that makes sense. So if it was 2 here, 1 here, it would be 0 there at double the height. So AX is going to be 2 times AD, and AD is minus 1, 2, 7, and AX is minus 2, 4, 14, therefore. And to work out the volume of a tetrahedron, we have to use this formula, which is also, this is just the determinant of like A1, A2, A3, etc., etc. So yeah, we can just do that. Work out BX and CX by using similar things. You know, we find this, and then just double it, and this and double it. And then we take this determinant of this 3 by 3 matrix, and that gives us this, which is 848 once we apply the modulus sign. So that gives us 424 over 3. And thinking about it, due to the scale factor being 8, we're going to have 7/8 of the volume in this part and 1/8 in the top. So we just have to multiply this final part by 7/8, which gives us 371 over 3. And that is the final answer. So thank you for watching. I hope this helped if you did this paper or whatever. And I'd really appreciate it if you would subscribe so I can get more videos out.